study material for session 37. Good morning, friends. In this, we shall study about the probable error. Probable error measures the error of estimate for a sample from a normal distribution. Probable error measures the error of estimate. You have to estimate from a sample. What you have been selected, the sample from the population. Any error is there. If it is error is there, how much error is there, whether it is significant or significant, that you have to study in the probable error. So here the error of estimate for a sample from a normal distribution. It helps in determining the accuracy and reliability of the correlation coefficient. Probable error which measures or determines what is the accuracy you have been selected, the sample which has been selected from the normal distribution, to what extent it is correct. Because here what the tools you have been used for the samples derivation, from the sample derivation from the population, this whether it is significant or not significant, because the from the samples have been selected, the management will take the decisions. If the samples which has been taken go wrong, then the decision also go wrong. For this, you have to carefully select the samples, because in many situations it is not possible for us to select the or test each and every data. So here we select some and then we test. So in the selection of the samples, any error is there. If the error is more or less, we have to know about it. How we can know about it? By applying the formula that it is the probable error is equal to, it is the 0.6745 into 1 minus r square divided by root n. 0.6745 is the standard error. It is called as the standard error. It is possible, usually it is possible in many cases of the samples you have been selecting. So for this, here 1 minus r square has been used. Here r is the correlation coefficient. R is the correlation coefficient, which can be calculated with the help of the actual mean method or by assumed mean method. Whichever it is convenient for us, we can calculate the R, and the R calculation which has been derived. This value we have to insert here, that it is the square. If we get the 0.5, 0.5 is the correlation coefficient. 1 minus 0.5 square, that is the, you have to calculate here, divided by root n. N means number of pairs, that is the root n. So by applying this formula, you can calculate the probable error. Now 0.6745 is the standard error. R is the correlation coefficient. How the correlation coefficient have been derived? You can calculate it by the direct method, that is the actual mean method, or by assumed mean method. Then you have to divide it by root n. N means it is the number of pairs. Here two series are there. You are calculating the correlation coefficient for the two series. Here how many pairs are there, that you have to count and insert here root n. If you simplify this one, you will get the probable error. This probable error is helpful for the management in interpretation of R by using probable error. How means, here say, if R is greater than 6 PE, PE means probable error. By applying this formula, we will get the PE. PE means probable error. 6 into PE. If you multiply the 6 into PE, if you get the value and you have to compare with the R. R is greater than 6 PE, then R is significant. Rank, that is the correlation coefficient is significant. So this is the interpretation you have to give. And the second one is, if 6 into PE means probable error, 6 into PE multiplied is less than the R, then R is insignificant. Here correlation coefficient is insignificant. So this is how we go for the decision with the help of the probable error. And now, in order to have the clarity about the how the formula can be applied and how you can derive the probable error, here we can take one problem on calculation of P and R. Here probable error is equal to R is equal to 0.6. R means correlation coefficient. They have given that if you are having the correlation coefficient as the 0.6 and n is equal to 64, n means number of items, number of pairs here. N is equal to 64. In a study, 64 items has been selected and you got the R as the 0.6, and now the probable error of the coefficient of correlation. You have to find out the here probable error. Probable error, it is equal to 0.6745 into 1 minus R means 0.6. Correlation coefficient in the given station or in the given series, it is the 0.6. 0.6 square divided by n is equal to 64 root of n. Then probable error is equal to 0.6745. 0.6545 is the standard error. It has been given that standard error of the with 0.675, that you have been inserted here. Then 1 minus 0.6 into 0.6, it is the 0.36. Then root 64 is equal to 8. Probable error is equal to 0.6745 as it is. If you deduct the 0.36, 0.36 is what? It is the R square. R means 0.6. 0.6 into 0.6, it is the 0.36. Deduct the 1 minus 0.36, so that you will get the 0.64 divided by 8. You have to first divide 0.64 divided by 8. You will get 0.08. Now 0.6745 into 0.08, it is equal to, will get, if you multiply, probable error is equal to 0.053. So this is the probable error. Here in the problem, you have to determine the probable error. What do you mean by probable error? It measures or estimates the, for a sample from a normal distribution. What is the error which has been arrived? Here the error arrived is 0.053, and if the management asks, you have to compare. In the problems, if they ask that it is the how to compare, means at the time you have to compare. For your syllabus, only the probable error has to, you have to determine. You have to calculate the probable error. Then in the same way, another one problem is there. If R is equal to 0.9, R means correlation coefficient, and n is equal to 100. Here number of pairs are 100. Find probable error. If you apply the formula, what is the formula? P is equal to 0.6745 and 1 minus 1 is standard 1 minus, here you have to substitute the value R is equal to 0.9. 0.9 square. If you multiply 0.9 into square, you will get the 0.81. Then here n is equal to 100. You have to substitute the value here. Root n means root 100. Root 100 means it is equal to 10. It is equal to 10. Then if you simplify, here 0.6745 into, in the same way You have to substitute the values. You will get the probable error as the 0.012. So this is how we can calculate the probable error. Thank you.